Hello friends, I am Dr. T.Y.B.Sc.Sem V CH-501, Arts, Science and Commerce College, Shahada, Department of Chemistry. For the T.Y.B.Sc. Semester 5, for the subject Principles of Physical Chemistry, CH, that is course number CH-501. This is our 8th lecture for this course and 6th lecture for the unit 2nd, that is chemical kinetics. We have already studied about rate of reaction. We have derived the equations for first order reaction, second order reaction. Then we have studied about the energy of activation, activated complexes, how they are forming. So now here we have to study the collision theory. There are two theories of reactions rates. First is collision theory and second is activated complex theory. So collision theory was proposed by Arrhenius and the Van Top, while the second theory, that is activated complex theory, was proposed by Eyring, Pilani and Ivan. So these are the scientists who discovered these two theories. Now we have to study the collision theory of bimolecular gaseous reactions. So we have already studied the kinetic gas equation in first year B.Sc. So there are many assumptions which are considered here. Kinetic theory of gases explains this collision theory. According to kinetic theory, the gaseous molecules are continuously moving and they collide, and while colliding, collision takes place. So the collision takes place when there are two or more gaseous molecules are involved in this reaction and they have associated with sufficient energy so that molecules are activated. This means that all the collisions are not effective. The effective collisions are in fraction. According to kinetic theory of gases, the number of collisions per second per centimeter cube is given by this equation, that is Z is equal to 2 n square d square 8 pi kt upon mu raised to 1/2. Call it equation number 1, where n is number of molecules, d is collision diameter, k is Boltzmann constant, t is absolute temperature, mu is reduced mass. Consider two gases A and B are reacting, and we can calculate here the number of bimolecular collision per second per centimeter cube, which is given as ZAB is equal to Na Nb d average bracket square into bracket 8 pi kt upon mu raised to 1/2. Call it equation number 2, where Na and Nb, small n A and small nb, are the number of molecules of capital A and B, that is two gaseous molecules, and dAv is the average collision diameter, which can be calculated as dA plus dB upon 2. This is the average diameter which is calculated and consider in this equation dAv. Mu is reduced mass, which can be calculated as Ma into Mb divided by Ma plus Mb. So here this is the reduced mass. Therefore, number of collisions in terms of molar masses A and B, that is Ma and Mb, is given as ZAB is equal to Na into Nb dAv bracket square into another bracket Ma plus Ma into Mb pi RT raised to 1/2 upon Ma plus Mb. So here Ma plus Mb. This is equation number 3, and hence from this equation ZAB we can calculate. ZAB, that is the number of collisions per centimeter cube. Friends, we have the equation number 3. In last slide, it was some wrong. It should be corrected as ZAB is equal to NA into NB, D average, bracket square into another bracket, MA plus MB divided by MA NB. So here is MA into MB and MA plus MB. This should be corrected in last page. So 8 into 8 pi RT bracket raised to 1/2. This is correct equation number 3. So now let us consider the reaction H2 plus I2 gives 2HI. We have to calculate ZAB for this reaction at 700 Kelvin and 1 atm pressure. So we have to calculate for this reaction ZAB, that is the number of collisions. Take a quantity of gas 1 mole for each. NH2 is equal to NI2, that is approximately equal to 10 raised to 19 molecules per centimeter cube, and DH2, that is diameter of H2 2.2 angstrom and diameter of I2 is 4.6 angstrom, and the average diameter can calculated as DAV is equal to 3.4 angstrom. So this is the angstrom, that is the unit for average diameter is in angstrom. MH2, that is mass of H2 is equal to 2 and mass of I2 is equal to 127 into 2, that is 254. Putting all these values in equation 3 and we will get the equation ZAB is equal to 10 raised to 19 bracket square into another bracket 3.4 into 10 raised to minus 8 bracket square into another bracket 2 plus 254 bracket complete into 3.142, that is the value of pi is 3.142 into R 8.314 into 10 raised to 7 into 700 divided by 2 into 254 bracket complete raised to 1/2. So this is, by simplification we will get 10 raised to 38 into 1.16 into 10 raised to minus 15 into 10 into 5.58 into 10 raised to minus 5, which is approximately equal to 10 raised to 29 per second per collision. So this is the after calculated value for ZAB for the reaction H2 plus I2. Thus there are approximately 10 raised to 29 collision per second per centimeter cube for 10 raised to 19 molecules of each species. But each molecule makes about 10 raised to 10 collisions per second with the molecules with other species. However, predicted rate of reaction is complete disagreement with the experimental rate. So this is there is difference between these two. This is experimental, this is theoretical. So there is disagreement between these two values. Hence, all the collisions do not result in chemical reaction. In order of reaction to occur, the energy of collision must be equal or expected threshold energy, the effective energy, not the kinetic energy of the two colliding molecules. Thus, the collisions theory is applicable to simple gaseous molecule reactions. That is, on the other hand, for the reactions between complicated molecules, the observed rate is found to be much smaller than the rates may vary by the factor 10 raised to 5. So this factor is showing the vary in the rate of the reaction. Friends, the discrepancy is explained by the fact that the colliding molecule is treated as hard species having no internal energy. Again, spherical model ignore the dependence of effectiveness of the collision on the relative orientation of the colliding molecules. So there are some discrepancies in the calculated values and observed theoretical values. The collision theory generalized by the introducing the factor P in the equation of bimolecular rate constant, and here we can write K2 is equal to P into A into e raised to minus EA upon RT, equation number 4, where P is also called as steric factor. The value of P varies from 1 to 10 raised to minus 9. When P is equal to 1, the reaction obeys collision theory, and when it is varied, the reaction does not obey the collision theory. So here in this equation, EA is energy of activation, T is absolute temperature, R is molar gas constant, and A is the Arrhenius constant. So in this way we have completed the unit 2nd for the T.Y.B.Sc. semester 5 students for the subject of principles of physical chemistry. So for this last topic, there is one question. Discuss the collision theory of biomolecular reactions. It is asked in the examination for 6 marks. So this is very important part of this chapter. Thank you.